Hey, what's up? We're back. You know what we're going to do now? We're going to prove logical truths. We've been talking about arguments all this time where we have multiple premises and a conclusion. Well, with logical truths, all we have is a conclusion. All right? So here's what we're going to do. We're going to derive this conclusion, prove it. We're going to prove that it actually is a logical truth. But how are we going to do this if we don't have any premises? Well, we're going to have to use either indirect proof or conditional proof on our first line. We have no other choice because I don't have any premises to work with. So I'm going to have to assume something. So in this case, since we're looking at a conditional statement, you can probably guess that we want to start by assuming a conditional proof. And that's exactly what we're going to do. So at 1, we will assume X via ACP. Okay? Now that I've done this, and we talked about this in the last couple videos, I'm going to do another conditional proof inside this conditional proof. Because if you notice, I have a conditional as the second part of my conditional. I have an X as my antecedent and a conditional as the consequent of this whole conditional. So we're going to move in, and we're going to assume the W on line 2. Now what I can do is I can, from line 1, because I have an X, right, I can do an X or X line 2 from line 2 addition. Because remember, I'm saying you got an X right here. I'm telling you that. You have an X. So if you have an X, you have an X or anything. You have an X or an A, an X or a B, an X or a C. So clearly you have an X or an X. All right? So next, we're going to take our tautology rule from our rules of replacement, because X or X is a tautology. And now what I can do is close out this conditional proof. We pull it back out. I assumed if I had a W, and I derived an X. So if I have a W, which I do, then I have an X. This is from line 2 through 4. CP. Now, remember we began by assuming X in the first place. I assumed that I had an X. I derived the W, then X. Therefore, I know if I have an X, then I have a W implies X. So we can then, and honestly, this one should be out a little farther. We drop back out. X implies W implies X. This is coming from 1 through 5. Conditional proof. Okay? Now you can probably see I'm almost done with the problem at this point, because by the rule of addition, if I want that P, all I got to do is add it in there. So at line 7, I've got X implies W implies X, or P by rule of addition. 6 addition, which is exactly what my conclusion states. So this is how you go about proving logical truths. And a lot of the time, you're going to see a conditional proof inside a conditional proof, but you're always going to have to start with either a conditional proof or an indirect proof. So next time somebody tells you you can't handle the truth, you tell them you can handle a logical truth, and you prove it to them. All right? I hope this helps out.